Alright everyone, welcome back. This time I want to ramble on a bit about a new multiplayer template that Unity just released about a week or so ago. And this is the competitive action multiplayer template. And this template is a first-person shooter that is using entities or netcode for entities for the client prediction and also using the multiplayer services SDK in order to create sessions and lobbies and whatnot. And this is kind of a bare bones, super simple first person shooter that demonstrates basically using all of the multiplayer assets that are now available. This is using Netcode for entities. It is using the Netcode character controller. Talked about this a while back, maybe last year. Multiplayer play mode, the entities play mode tools. It has different services set up as well. The lobby and relay using the sessions. It also has matchmaker set up and for multiplayer server hosting as well. The minimum requirements for this is Unity 6.0.28 or later. As of this recording, 0.32 is out, and that's what I have installed here. So as you can see here in the hub, when you make a new project, you can install a number of these templates here. And you would just download the template, and after you download it, you can set up your project name and everything. For this particular here, this will give us a number of tutorials once you have everything downloaded, and we can start a few of them. And it just goes over the basic structure of the project and how to set up the different multiplayer services. Right now, I just have the relay set up. I haven't set up the matchmaking or the dedicated servers just yet. But yeah, this is basically the built-in tutorial. We're not going to go through the whole thing, but it will show you the different folders and stuff for it. Go through the quick play tutorial. Do again. All right, so from the main menu here, we don't have any, there's no audio or anything set up here. But you see over in our hierarchy, I have the entities hierarchy set up here. And what this ends up doing is from the main menu, it loads up a couple of subscenes that has entities built into it. This one has our environment here in the background that we're rotating around. This is basically the main game where you have your spawn points and the global volume here for the post-processing effects. We also have these game resources. These are basically all of our ghost objects that we're going to be spawning. Have some settings, our despawn ticks, how many seconds to take to respawn, our player ghost, our character ghost. If you're not familiar with the entities character controller, it's basically split into two parts. There's a player, which has all of your inputs and stuff set up on it, and then the actual character ghost, which is your in-game representation. And if you're using the third-person character controller, there's an orbit camera that can also be set up and tied to your action. We have all of our weapons here that are set up as prefabs that get baked over into entities, our spectator cam, our name tag, and the various special effects. The bullet effects and the hit effects are just your standard visual effects graphs that will get spawned where they get hit. All right, so let's just show a little bit here on what this actually looks like. So here is where you can create a game, join a game, or matchmake. Like I said, I don't have matchmaking set up. Can change the name if you want. I'm just going to keep it as this. This gets saved out into the player prefs, I believe. So this will like auto repopulate. Top here just has some debug stats that are done using the UI toolkit. That's all of these down here. And you can just hit I to toggle that on and off. All right, so we're gonna create a game here. This is just an empty scene. This is a rocket launcher, I guess. Really do need to add some sound to this, but you can jump and blow yourself up. 4 seconds here. There are 16 spawn points, I believe here. There's, you don't have to fall off the map or anything. There are different weapons. You can't actually switch between weapons in this. Just when you die, you get another random weapon. Plasma weapon. You have a right click to aim, which is just messing with the field of view to zoom in. I don't think it actually affects the weapon spread or anything. Right now, for this one, I just want to go through a bit of the netcode side of things, getting connected and whatnot. Might do a separate video on how the weapon system actually works. You can press the K button to respawn yourself if you want to see a new weapon. And you can, laser. We have a settings menu here. These will also all get saved to the player prefs here as well. And if you go into demo tools, this is working as I am in. So one thing to actually keep in mind here is if you are connecting to Relay, you cannot use your thin clients here because the Relay requires a full client connection in order to connect to it. So we will need to, out of this, here under the services folder, we have a service setting here, and we need to switch this to direct. This is if you are starting from the game manager. We can also just start from our game scene directly, and this will start a local host connection for testing purposes here. And we can get 5, good. Here, and you can see we have our 5 thin clients and have dudes. And when you kill them, they will respawn in one of the random respawn locations. They do check if another person is near this location. So if I'm standing here, they won't just respawn directly on top of me or inside of me or whatever. This map only has 16 spawn points, so this is going to be a 16-player map. Could technically put in more than like 20 thin clients, but you'll have to wait in order to respawn. And we can show that 20. See our ghosts show up here, and since they are waiting to respawn, they just keep respawning at the same spots. So if we were to blow ourselves up, it's waiting for a free spawn point. So there won't be one until another 5 people die. So we're kind of stuck there. All right, anyways, let's talk about how this actually works. So if you remember when we have talked about Netcode for entities in the past, there is a client server Bootstrap that will automatically create your client and your server worlds on startup. Now what we have here is a class deriving from the client server Bootstrap, so we can have our own custom logic going on here. And basically what this does is if we are in the main menu scene, it is going to disable the auto connect. And that means we will have to create our client and server worlds manually, which is fine because we'll be using, from the main menu, you can have different connection types. So you don't really want to do these automatically. If we are logging in from the gameplay scene directly, then we do want to have our Bootstrap log us in for us. And we have the different play type roles here in something. So here we can choose the different play mode types. By default, it's client server or a host. You can also have just a server or just a client if you have another dedicated server running somewhere that you want to connect to. And so the first thing that it does after creating the client world or not is we load in our game manager prefab, which we grab from our resources folder here, and then we instantiate it. And this will also have the other gameplay settings and whatnot loaded in as well as the game resources scene gets loaded in with the game manager. And then we just tell the game manager to start our client world and server world. The game connection here, this is just, this is starting all of the multiplayer services SDK. So this is how you start your session and you join your various sessions from here as well. So when you're using Netcode for entities, you have a special network handler that you'll need to use specifically for entities, and that is set these network handlers. And basically everything else after that is the standard sessions logic that we've used previously. You can join session by code, you can create or join matchmaker or quick join, the different queues. This one you can matchmake into your dedicated server, or you can matchmake into your relay. And these queue names, I believe, are set up in a services folder here. And here's the matchmaking. So you can use these scriptable objects to upload into the cloud service, which I believe this has deployment set up here. So here, it actually deploy, we'll see. And then we can check out the cloud view just to see. Anyways, while that's doing that, we have our create game, which is our session options, the options with the network handler. Then we add the connection points and ports. So how the game objects get and the prefabs get ported over into the entity's worlds are through these authoring components. And these are mono behaviors that live in subscenes in the inspector here. Still go. So basically, these public fields here are what you set in the editor, basically before you build out and everything. And here, this Baker class, this is what takes these fields and they will create an entity and then add the components to it. So this will create a game resources authoring and basically assigns all of these managed components into an entity component. You have a dynamic buffer, which is basically a list, and this is going to be a list of weapons. So for each of our weapons in our weapons ghost count, you'll just create a new entity for it and then add it to our list. And this will be what the player gets when they respawn. That didn't work at all, probably because I don't have the dedicated server set up. So that's yeah, because it doesn't have it's all fine. Okay, and it does the same thing with our special effects as well. This is in, but there is an enum of hit effects that these bullet and hit effects have to match up to the enum order, just in order for the array to function right. And then we add these to our hit effects dynamic as well. And these are the component data. So these are just structs that you can attach to entities as components. These are our game resources. You can look these up through your systems that we'll look at in just a second in order to reference some of these objects. So our game manager here is just a regular mono behavior. And this is going to basically keep track of the actual moment-to-moment gameplay here. We have our max player count at 16, our different menu scenes. This will be loaded in from the main menu as well. So I think this is set to do not destroy on load, but it's also kind of a singleton as well. So here we grab our inputs, our scenes loader here. This will actually load in our different sub scenes depending on if we are client or server. And then this also will load in the resources. Yeah, our resources and our gameplay scenes will all get loaded. Here we'll load our scenes, and they are loaded in additive. Okay, that's really it for actually connecting. They will wait for ghost replication to happen. And here is where the client server Bootstrap will create our server world and our client world. You also do want to destroy the local simulation world. And yeah, the rest of this is just for UI stuff. Okay, so after the client and server worlds are connected, we actually have to join the game. And with the client and server worlds connected, you have limited connectivity here. There's no syncing of ghost data or anything happening at this point. It is all you can really do is send RPCs back and forth. And the first RPC that you want to send from the client is a join request. And you do that by sending a struct that implements RPC command. And that's really all you need is just the RPC command. We have a respawn request here that is empty. But if you want to send data with your RPC, then you can send it here as these public variables. So here we're sending our player name and whether or not we are a spectator. So that is our status system. So here in the client game system, this is a partial struct that implements iSystem, and these all have on create, on update, on destroy as well. I think we're actually using this one. And these basically correspond to the mono behavior lifecycle, like on create, on enable, on update, and on destroy. And these basically, well, on create is where you kind of put your initializations for your system. And also you have this require for update. So this will prevent the updates from running unless there is this this entity in the system. So all of your systems will basically be running constantly, whether or not there's data for them. So you want to make sure that the system itself is only updating when there's relevant data to be had. And for our client game system, we just really need our game resources, which is basically have all of our settings and whatnot here. So on update, we want to, well, this is just to disable some dynamic contacts if it's there. To get our game resources, we just need to call the system API.getSingleton. This is only used when you have just a single entity that's been created, and our game resources, there's only been one created. So we can get it as a singleton, and then we can reference it later. And later is right here. So here we have a handle join request. And for this is actually how we send the RPC. And that is going to be creating an entity, which we will just create it through our system state that gets created with the system, and our game sources. We'll use that in just a second. But first, we want to make sure that we have well, if we don't have a network ID, which is what is created with when the client world and server world connect for the first time, you get a network ID. And we also, if we are already in game, we just want to return. Don't want to do anything here. So after we connect with this join request, our connection entity will have this network stream in-game component added to it. We don't have either of these, we just bail out early. So here we are going to create an entity, and then it's going to be created with this client join request RPC component and this send RPC command request. This is what actually sends it to the server. Grab our player name from our game settings. If it's a thin client, generate a random name. And then here, this is where we are setting those two public variables from the RPC request. We're setting it if we are a spectator, we set our name, and then we will set the component data from the state entity manager, set component data, have the entity we just created up here, and then we will set the client join request RPC to this that we just created there. And then we will add that component, the network stream in-game component, to our client entity. And once these get added, there's an RPC system that will automatically just send out any RPCs that have been created. And these are for our spectator mode, which is just going to be local only. All right, so here in the next function after we send the join request, we'll handle the character setup. And the first thing we do here is we have a entity command buffer. This sets up basically a list of commands that we can run after we finish adding things to it. So we have this for each function, which for our system API, you can basically query all of the entities that are currently created, and you can do all of your operations on them. So what this basically this job will do is this will find everything with a first person character component that have the ghost owner is local, owning player, and ghost owner components that have the character initialized component disabled, and then we get our entity. So basically what this is doing is this is going to grab our local player character. So once we have this, and there should only be one, we need to set our main camera to be this character's view entity. We give it our base field of view. We also have a buffer lookup. So what this does is this will grab every entity with this child component and then basically sends it into this buffer list. And then we have a miscellaneous utilities class here that basically sets the shadows for our local character. All right, so once we've gone through our local characters, then we have our remote characters that we'll go through. And it's basically the same, just without the ghost owner is local, but you also want to make sure that it has not been initialized already. And this is just setting the name tag to whatever that owning player's tag will. And finally, we just do the same thing again, but this is with our physics colliders. And when we do the query, we reference them as read write. And also for our character initialized, you reference them as read write, and if you are going to be modifying them at all, and then that way we can just grab the physics collider value, make unique, and then we also will set our character initialize equals to true. So this will only happen for these characters. Okay, so on the server side, we have a couple of components here. We'll have our random number generator. We have a spawn character component. We also have this gameplay maps buffer element data. This should probably be renamed something a little more intuitive, but this is basically mapping your character controller and your player with the connection. And there is also a remap to that will get used when the character is actually spawned. So here in our system, I don't remember if I said that or not, but the world system filter, this will actually control which world this system actually runs in. So this system will only run server simulation. In our client system, this will run in our server simulation, also in thin client simulation. So here in our on create, it's only going to run with the physics world singleton, our network stream driver, and our gameplay maps. Here, this is just getting a random seed. This is using unity.mathematics random, which is more deterministic than the regular Unity engine mathematics, I believe. All right, so here in our update, we are just grabbing that dictionary, basically grabbing the actual entity that has those on it, getting our network stream, and then we are making sure everything is updated. Here we have our entity commands buffer that is going to be in the begin simulation entity command buffer system. Here again, similar to our client, you're going to handle the join request, handle the characters, and then handle any respawn requests. There's a separate RPC that we could use in order to just respawn our character. All right, so the gameplay maps here are just going to roll through all of our connection events, and if that event says we are connected, then we loop through and we will add a new element to our gameplay maps list, and that's just going to be the ID that we have just connected with. So our ID value, action entity will be, all right, so here is where we actually handle the RPC that was sent from the client. And for this, we are just looking at all of the client join requests from the receive RPC command request. And basically, we are just checking that our source connection has a network ID and that the source connection is not already in game. So here we grab the network ID, we will spawn our player. So that's with the entity command buffer.instantiate. This will spawn the player ghost that we can grab from the game resources. We remap the actual owner ID and the first person player entity to these in our gameplay maps. We will set the owner of the owner ID to the ghost owner of the player entity. We also need to add the linked entity group to this source connection. So when the connection goes away, when we disconnect, we want to destroy the player entity, and also the character should be linked to this as well. Here we are going to set the player to our player entity, which has our player name in it, which is what the name tag is going to end up being set to as well. And then here is if we're not a spectator, then we actually spawn our player character, which there is a separate spawn system. Should be in the server, player control. Anyways, doesn't matter. So this will add a new spawn character request from our delay. This will spawn it immediately because we are first spawning in. Then we'll add a new joined client to our source connection. Then we add the network stream in game to our source connection. Here's some little debug, and then we just destroy the RPC entity here at the bottom. Here in the handle characters, this is actually where we spawn the character. So we are going to need the physics collider and make sure that our characters have already been initialized and that they're the first person character component. Grab all of our members that we need here. We're going to grab all of the spawn character components and their entities. And then if we have the network ID and we're joined, try to find a spawn point here. I believe this will somewhere, right? Basically what this is doing is finding the spawn point transforms, and then we are looking for check sphere, which is basically a sphere cast around the spawn point and making sure that nothing is actually blocking it. If anything is blocking it, then we move on to the next spawn point. So we found our spawn point. We are going to grab our character ghost from the game resources. That's just our up direction. Set our character to the resources character ghost. And then here we actually spawn our actual character in game here. So we are going to instantiate ghost here. We add the character to our gameplay maps, and then we set our ghost owner, our transform to our spawn point location, and then we set the owning player to the player entity of us. And then we add our character to the linked entity groups as well. Here is where we assign the character to the player. So our player inputs and everything controls this character. Set that up. We will give it a random weapon. You can set it to force the first weapon, and then afterwards you'll get a random prefab whenever you respawn. And then here we will instantiate whatever weapon we've got, and then we set the weapon to our owner, or set our owner to the weapon. Then we set that weapon as active, and then more debug stuff there. We'll destroy the entity, the RPC entity. Then we dispose of the spawn points and the consume spawn points for next time. We went through that. This is the handle respawn request. So I think it's the K button forces you to respawn. And that's all what this does. Basically what this does you have a health component. This will set that component to 0, at which point you die and the death system takes over. Okay, I think that is all I wanted to cover right now. That is our spawning thing, connection. Could check out player really quick. Here, we're just going to be a client. All right, so you can tell here that even though I'm paused on the main screen, it's not actually paused in the game. but it's definitely killing my frame rate. Okay, is so yeah. I think next time we will go through the weapon system and how the different effects are spawned and how all that works. So there's a whole other group of systems just handling the special effects and the damage and health and dying and respawning and all that. So yeah, it's been about an hour, so we'll just go ahead and wrap it up here. And yeah, we will see you guys next time.